Today we are going to see a very important topic that is called netting. Okay, so now uh, please think in this manner. Uh, this is your office. Okay, so this is your, you can say, your LAN. Okay, and this is your router on the top of. Okay, and here your all switches, your course. I'm not drawing everything. You will have a firewall here, then your core switch, then your access switch and all. So let's say you have a users here. Please understand very clearly. I will try to do my best to make this very simple. Okay, so your LAN subnet is, what is the subnet? 192.168.10.0/10. Okay, so what happened is now you have all the routing, your all STP, everything is working fine. Okay, and this internal user, see this is, let's say this guy is 10.10. This guy is 10.11. This guy is 10.12. Like this, similarly your gateway is let's say 10.1. Okay, and then here between, between this core switch and the ISP router, so there will be different network, and there should be some default route we give on the static our core switch, saying that if you want, anyone want to go to internet, just go to the ISP. Okay, now this is called your intranet. Intranet, it means within your LAN, within your boundaries. So now you got the internet access. Okay, so you got the internet access, and your router is connected to the ISP router, ISP link. So as I think everyone know that how the ISP is. Like if you have a Wi-Fi at home, so what happened? The ISP provided you a cable at your doorstep, right? And what you did, you connected a Wi-Fi device to that cable, and you configured that router, and you're accessing. So similarly, in organization also, ISP will provide you this LAN cable. Okay. So now what we do, again here on ISP router, we do default route towards ISP 0.0.0.0.0. Okay. So okay, now this guy, what is this IP address of this guy? This guy IP address is 192.168.10.1, 10.10. So he want to access the Google. So it went here. Let's say Google IP address is something uh, a dot a dot a dot 8. This is a your Google server, Google. So this guy want to go, so it will go to the L3 switch. So first it will go to the gateway. So gateway will say no, a dot, no, it is not in my routing table. So he will just forward to the default gateway. A router will see. Router will say in its routing table. Do I have a dot, a dot? No. But no, if I don't know, then I will pass it to my default gateway. I think it should be internet. Then it will, when it will go, see, the source, your source, who is the source? 192.168.10.10. And where you want to go? A dot a dot a dot 8. So when he try to go here, the ISP will drop this connection. You know why? Because there is a RFC rule. This is called RFC rule. Remember this point, very important. So RFC rule, what it said, any private IP. What is the private IP? 192.168.0.0 slash 16 172.16.0.0 slash 16 and 10.0.0.0 slash 8. So any range. And can anyone tell me what are these IP addresses? Come on, first.
Slash
Private.
24 is it?
Yeah.
191.68
Okay, okay.
slash 24.
Yeah. So what are these IP addresses? Private.
Yes.
So these all are private IP addresses which we use in our LAN. Okay, we use it in below here in your LAN. So the RFC rule said any private IP address is not allowed on the public IP address on the public. As a see as a source 192.168.10.10, it was going to 8.8.8. So ISP blocked that. No, I cannot allow you because you are private address. So what is the solution? The solution is, if you want to go to the private to public, then the solution is only NAT, network address transfer. Okay. Network address translation. So here, so the solution is only you need to have a NAT. So what the NAT does? So what the NAT does is, let's say you need to for this there are two options, multiple options actually to have the NAT. See this ISP, your internet router interface. This is actually the uh, connected to the public network, and this interface of your router, it is connected to private network because it will be a private IP address, but it will be public. So what you can do, you can make so whatever the traffic coming from inside, okay, you can say go to the NAT. So it will convert your private IP address to the public IP address, and where this will happen on the router itself. So router will start maintaining the NAT translation table, that this is the private IP address he is going to, and this is the public IP address. So like this it will maintain the NAT address table. So what is the NAT? So private IP addresses are not allowed on the internet. So NAT, with the help of NAT, we convert private to public IP address. Okay, so we convert private to public. So this 192.168 cannot, he cannot go here. So let's say if suppose your public IP address is 1.1.1.1. So the router will change that source. Source, instead of source 192.168.10.10, it will change to the public IP address as a source. Then it will go back here, and then this is allowed. So he will access when it is returned back. When it return back, then router will see, okay, 1.1.1 is actually the 192.168.10.10. Then it will send that. So where this thing happen on its NAT translation table. Okay, very clear. So NAT has three types. One is static NAT. Okay, static NAT is mapping, one to one. So in the static NAT, what you want is, let's say, now we understand that, okay, one to one. Let me write it down. Second is dynamic NAT. So it will be many to many. Okay. And the third one, which is the most popular, that is called PAT, port address translation. Okay, these are the three types of NAT. So let's see one by one. Okay, NAT. So static NAT. This is static. One to one. You mean, see, for the static NAT, what it is one to one mapping. So let's say it is 192.168.10.10. So if this machine want to go to internet, then you need to reserve, you need to buy a one public IP address for this guy, one public IP for this guy, one public IP for this guy. So three public IP are assigned. So you need to go to the router and configure here. Say that you need to configure the NAT on the router, saying that for 192.168.10.10, the oh, okay. So 192.168.10.10, we reserve 1.1.1.1. Okay. Then for 192.168.10.11, we reserve 1.1.1.2. And for 192.168.10.12, we reserve 1.1.1.3. So now see, this is a static mapping. So the agent, what I need is, so static NAT for static. My lot of disturbance here. No, every seller is coming to your door, vegetable and all,
Yeah.
and
Yeah.
they're using the mics.
Oh yeah. You want to say quick.
And Muhammad, you still like India?
Yeah, I like that.
Okay. So okay, let's go back here. So what we understand with the static NAT, for every machine, every single machine in your network, if they want to go to internet, you need to buy a dedicated public IP address for them. And you know, the as we discussed, public IP address is a paid one. It is a paid one. So you need to buy single public. Let's say if you have 40 machines in your organization, 40 users, so you need to buy a 40 IP addresses. Will it be cost effective? No. This is very expensive. And also remember our IP version 4. IP version 4, it has, what is the limit? It is a 32-bit IP address. And we know that its range is 0 to 255, and it has the 4 octet, like say, 4 octet. It is represent like 0 dot. This is first octet, second octet, third octet, and fourth octet, right? So in this octet, either 0 or 255 should come. So don't you think that IP version 4 is going to finish in the world? Because now see, now the rule, you know that every single machine, if suppose you buy these three IP address, 1.1.1.1, 1.1.2, 1.1.1.3, so these three IP addresses is dedicated to your organization. No one can use in the world. I'm talking about world. So no one in the world can use that IP address. So like this, see how many machines in the world. If everyone buy the IP addresses for their machine, so do you think the IP address 4 range will be remain? Do you think that IENA still have the IP addresses? Do you think that the there it must be finished, right, till now? So yes, so that is why there is a threat still that IP version 4 is going to end. That is why the IPv6 came into picture. IPv6, they introduces IPv6. It is a 64-bit. And you know the IPv6. IPv6 is something like it has n number of IP addresses. So even every um, what to say, like every machine in the world, even it is a mobile, it is a laptop, it is a TV or whatever digital. If you assign the IPv6, so still it will not be finished. So this is the future actually, IPv6. But it is going to come, but not every organization use this. But you know what, IPv4 still become, it was actually about to finish, but one technology came in the NAT and it saved the IPv4. That is called the PAT. We are going to see that now. Okay, so first thing we saw that static NAT, one to one. So for every machine we want a public IP address, one to one. So we said no, it is not possible. Okay, then fine. Then take the dynamic NAT. What is that? Many to many. So it is the same. It is the brother of static NAT. So what does it mean is, so in the dynamic NAT, as you know, in the static NAT, the 10.10 is reserved for 1.1. 10.11 is reserved for 1.2. 10.12 is reserved for 1.3. So in the dynamic NAT, what will happen? So the 10 can go take this guy, 11 can take this guy, and 12 can take this guy. That's only the difference. But still, if you have three machines, then you need a three public IP addresses. So still this is costly. Many to many. Dynamic net. No, I will not go with this because the public IP addresses are costly. If I have thousands users in my organization, so shall I? Do I need to buy the 1,000 public IP addresses? Will INA give me that? No, that is not going to happen. So to overcome these two problems, with the static and dynamic, but static still it is used. Where is the scenario? I will tell you. So when the static is used is when you have a public server in your organization. Let's say your xyz.com, let's say nextgen.com, that is inside. So this nextgen.com, this server is a public server which can be accessible from internet. So in this scenario, you need a public IP address, static IP address. So let's say if suppose you have 192.168.10.100, this is your private IP address. So you need to buy a public IP dedicated for static NAT for this guy. Let's say 2.2.2.2. So this is fine. Okay, one static NAT because this is a public server. Then you have dedicated NAT. That's fine. Static NAT. So static NAT use here in this scenario. But in this scenario, where the users, if you have 1,000 users, so are you going to buy 1,000 IP addresses? So that is why PAT came into picture, port address translation. So PAT, you know the PAT, what it does? It is nothing but it is also called many to one. Like your thousands of machine can be mapped to one single public IP address. That is the PAT. Now, can you tell me out of these three, which one is good and cost effective?
Huh.
Exactly, PAT. So port address translation. How the port address translation work is, let's say you have 192.168.10.10, this guy. 192.168.10.11, this guy. 192.168.10.12. Okay, like 192.168.10.254, let's say, your entire range. Okay, your entire range can be, your entire range of LAN can be mapped to a single public IP address. Single public IP address. That is nothing but, let's say you have taken 190, sorry, 188.68.48.56 something. So this is a pure public IP address. So you know what, with the NAT, so now you are going to, your router will have table something like this. Okay, so now see, this is your NAT is, it is your router table, let's say, and from here your internet is here. Okay, let's say 10, this guy want to go to the internet. So obviously he will be, his source will become this guy, and he will go. But immediately this guy came. So how this one public IP address is going to view to all? So you know, that's why it is called port address translation. So you know, we have the ports we will see in the firewall. The port range is 0 to 0 to 60, 65 65,005 26 something, some 5 digits are there. So this many ports you have. So what will, if suppose 10 gone, if 10 want to go to internet, so you know, the public IP address, it will be something like this. It will say I am 192, sorry, 188.68.48.56 column 1. Similarly, if other guy want to go to the internet, so it translate with the same IP address, same public IP address, but the port will be changed 84. Then someone want to go again. If this guy want to go, same, the port will get changed. Let's say 36. So like this, that's why it is called port address translation. Port address translation means your all IP addresses, your entire organization IP addresses, they are mapping to single IP address, but with different ports. And you know, you have 65,000 ports. So this many number of users can access, map to one public IP address. That is why it is called port address translation. Okay, static NAT, dynamic NAT, and the PAT. Any questions in this before we jump into the lab? Yes, no, never.
No, it's fine. It's clear.
This clear, right?
Mm. Yeah.
So uh, Omar, which NAT you want to use? Let's jump into the lab. So this topology will not use. We will open a new one. Okay, so we are going to see the NAT. So for NAT, what we can do, you can use a single machine, no problem with that. And instead of your entire LAN and all, I will just take one single router here. Okay, let's connect it here to here. Okay, next. Okay, so generally what will happen here is the ISP will be here, cloud. Okay, so what we are going to do is we are because see the cloud and all, this is just for imagination. This is just you can connect here. So instead of that, what I will do, I will take one of the servers. Okay. Okay. So let's say this is my 192.168.10.10. Okay. Obviously my gateway will be here 10.1. So let's say this is our public. This is something of google.com something. So this IP address we will see. Take this one 1.1.1. So obviously we will use our this interface 1.1.1. So we are considering here, and we are considering that this is nothing but the internet. Internet. I will use public. Public. See, public network. It is not a private. It is for everyone. Okay. Now let's configure that. So let's first queue the IP address to this our machine 192.168.10.10 192.168.10.1 gateway. Let's queue IP address to our server desktop 192.16 sorry 1.1.1.2 and see the subnet become this one. So I don't want. I will use 2.5.2.0 1.1.1.1 gateway is this. Okay, this is done. Now I need to configure my router. What I'm going to do? No, just let me check the interfaces. 0 by 0 going LAN, 0 by 1 is going out internet. Okay, so enable. I will give the host name as NAT router. For this lab, let's say NAT. Or generally, what we do, we say ISP router, which is connected to the ISP, which is going to the internet world. So interface. So if I see show IP interface brief, fast Ethernet, config terminal, interface fast Ethernet 0 by 0, IP address 192.168.10.1, 255.255. This is important. By default, router interface are shut down. So I'm going here 1.1. This IP address is IP address 1.1.1.1, 255.255.255. Can I try ping to my from ISP router to my LAN 192.168.10.10? Yes, I can ping. Similarly, can I ping to the public server 1.1.1.2? Yes, because so show IP interface brief. If you see here, so this is connected to your LAN. This is connected to your WAN. So generally, that's why we put the description in the interface 0 by 0 description connected to let's say private. right? Obviously, this is my private network, and this is connected to, I will say, public. Done. Okay, now say show IP route. So both routes are here. So now the question to Umar or Waris, can you answer me? Can for this lab, can 1 and 160 at 10.10 ping to 1.1.2, or you need a routing?
No.
Who is this?
What is?
No. Okay. Umar?
Um, yes.
Why? Because if you see here, this is nothing but directly connected, right? Both networks are directly connected.
Yes.
So obviously they will ping. 100% they will ping. Because the router know both the routes. 1.1.1.2. See, it is pinging. So only the in the real time it will not work. In the real time, the ISP will block that. But here in this lab, both are connected right directly, physically. That's okay. Now let's do the static NAT first. See now you can see that this guy is going here. He is able to ping, or there is something you can browse also. See, I'm in the machine. I can put 1.1.1.2. Can you see Cisco packet tracer? It is browsing also on port 80. So browsing is on this that server. Okay, now let's do that. Now let's configure the static NAT first. So static NAT 1 to 1. We know 1 to 1. Config terminal IP NAT inside address translation, right? So IP NAT I will say inside source. What is the source? Are you providing a list or static? So I'm providing a static. Static. What is the inside local IP address? My inside local IP address 192.168.1 dot sorry 10.10. This is my private IP address. Question mark. Inside global IP address, what is it is going to translate? So I am going to reserve this IP address. Let's say what is called 99.99.99.99. Let's say this is my public IP address. I buy for this machine. Enter. Done. What I did, IP NAT inside source static and this one. So one more thing is remain. You need to go to both interfaces. Fast Ethernet 0 by 0, which is going towards NAT. Just say here IP NAT inside because it is an inside one. Then just go to your external NAT, external network, and say here IP NAT outside. That's it. Do show history. So how many commands? Only this many commands for the NAT. I have the notepad for the NAT. Oh yes, I have. Okay, yeah, that's good. It is having all the things. So I can add here only again. One dot 20 dot 0. Okay, so what I did, I just put this three command. I will say static NAT. So what is the command? In the global configuration, IP NAT inside, and then we put this one. Exit, and then exit. And if I use here config terminal, so this configuration you can just copy paste and put it into your router. So you will have the entry. Okay, now done. So this is done. So now let's see what happen. What will happen? Nothing will happen. So, can this guy ping to this guy? Yes, it is still pinging. Done. Can this guy browse 1.1.1.2? Yes, it's browsing. But what happening here? If you see here, show IP NAT. Can you see? So when in the NAT table, the router is saying the inside local, this guy 10.10, actually it become, it went with the ISP. Can you see the ICMP ping? So it become 9.19.99.99. So where it is go, the destination is 1.1.1.2. When it come back outside global 1.1.1.2, again it is going coming back to 1999. Then it is going to this one. Four things. Inside global means you're public. Inside local, you're inside. So outside local and this one, if you see, both are same. And can you see here? Can you see your TCP? ICP means I send some ping request. Then TCP is nothing but, if you see here, this guy actually he tried to access this guy. You remember on the browsing what I did? I did 1.1.1.2 browse. Then browsing is nothing but the port 80. So I went there, but for this guy, my face is this one, 99.99.99.90, not this one. So this is how the static NAT is working. So what happened to this guy? He become 99.99.99 when it go out to the public. Who did that? Router did that. And how it is done? So see, you can see I'm pinging this one. So while pinging, my source is actually 192.168, but a router will translate that. It happened because of the NATing. 1.1. Let's say uh, HTTPS 192. Sorry, 1.1.1. See, still now I use the 443. 443. Go and check the NAT now. So previously I just used the normal browser. Now can you see here? See, I have the ICMP. I ping when I ping, so ICMP protocol. That's fine. TCP. First I try browsing with port 80. Then later I try browsing HTTPS. That's the HTTPS nothing but the port 443. So can you see it's happening? So this is your NAT table, NAT translation table. So every machine, sorry, this machine 191.168, it is translating to this guy. So this is a static NATing. So similarly in dynamic NATing, what will happen? So let's say you have multiple IP addresses here, 192.168, 10.10, 10.11, 10.12. Okay. So instead of here, what we do is, let me show in the notepad, it should be here. Okay. So configure static NAT, IP NAT inside source. See, you can take 3 machines and give these IP addresses. Let's say these IP addresses, and inside and outside. In the inside you need to say IP NAT outside, and you need to say IP NAT outside. And verify show IP NAT translation. So instead of here in this diagram, what you can do is instead of this one, okay, take the switch, and connect your 3 machines here, one here and one here. I'm not going to give any VLAN or something. This is just a flat LAN. Okay, and from here, just say this, and this machine will be 192.168.10.11, and this machine is 192.168.10.12. Okay, so this is the same, nothing will happen. So still I can ping that guy. So right now the spanning tree, can you remember? Orange spanning tree is there. So once it is green, my ping will go up. Yes, it's pinging now. See? But here I did not put the IP address. Let me keep it quickly. 192.168.2.168.10.11, 192.168.10.1. Sorry. And similarly, desktop, oh, sorry, 192.168.10.12, 192.168. That's done. So for these guys, I need to buy a new IP addresses. So how can I translate that? So I need to say show run. So config terminal IP NAT inside source static my 192.168.10.11. I'm going to give 88.88.88.88. Similarly, for my 12, I'm going to map it with 77.77.77.77. So let's try everyone. Let's try generating some traffic. Ping 1.1.1.2 is pinging. Browse it 1.1.1. Done. Similarly, go here. Ping 1.1.1.2. Done. Similarly, browse 1.1.1.2. Done. Browse. Similarly, go here. This guy also. Ping. Done. And browse 1.1.1.2. Let's go to the router and check here. Show IP NAT translation. Wow. Can you see the NAT table? 77, 88, 99. Okay, so guys, can you see this? For the 12, we map to 77. For 11, we map to 88. And this is how this happening. So this is all a static NAT. So for dynamic NAT, what we can do? So we will say here no. Similarly, we will say this one also no. And we also have NAT IP address. Copy, paste 10, and we give 99.99.99. Done. So all NAT remote. So IP NAT translation, nothing. Nothing gone. So if you see here the table, so okay, in dynamic net what will happen? So the same thing, but this 77 can come to 10, 12 can become to 88, and 11 can come map with the 77. So dynamically it will happen. But in static, we are defining manually. We're defining saying that source is going to this and this. Okay. So how the dynamic mapping will do? Just come down. So here, three steps. We need to create the ACL first. So we will create a ACL first, saying that this is our LAN permit 192.168.10.11, and we need to say IPNAT pool. I gave you the pool, saying that give the name CCNA and what is the public range you have 192.168.1 to 10, and the mask is this one. So this is your private IP address, this is your public IP address. Now map them to all. IPNAT inside source list 20 pool to CCNA. That's it. So what I'm going to do is creating the LAN access list. Access list 10 permit 192.168.10.0 0.0.0.255 wildcard mask. You remember that. So I created the access list. Next, I need to create the pool IPNAT pool. Give the name. Let's say I'm giving CCNA pool. Start IP address. So let's say I have purchased the IP addresses from like this 1.1.1.10, and is I have three machine. I buy three 1.1.1.13. Okay, and net mask is 255.255.255.0. Done. So now finally what I need to do, IPNAT source list. IPNAT source IPNAT inside source list. What is the list? 20. That access list. It is mapping to pool. What is the pool? CCNA. That's it. Done. So now let's go back again to these machines and browse it once again and generate some path. Here also just go 1.1.1.1 browse and ping. Similarly ping and browse 1.1. Done. Now just go here to a router, IPNAT translation. Something is stopping. IPNAT inside source list 20. Yeah, that's correct. Config terminal do show history. Okay, can you see source list? I created 10, I have given 20 here. My bad. Say no. This is how the mistakes happen. Copy. Paste. I need to say IPNAT inside source list is 10 and pool is CCNA. So IPNAT translation. The traffic again. Just select the ping. Ping. Now go here. IPNAT. Can you see? Now see 1.1.10 it went to this guy. For 11 it received to 11. For 12, see right now it receiving the sequence, but it can be anything. It can sometime 10 can become 10 can be 12. So that's what, that is only the thing. So that's it. And finally the pat is very simple. It is same like a NAT pat. So same, we create this one, and here instead of the range we give one single IP address. and we give, say that overload. So I'm going to show you that. Shahid, I need just 2 minutes.
Okay.
Okay, just 2 minutes. So config terminal do show history. So what I'm going to remove is no. I'm going to remove this guy. It is saying it is used, so I need to clear IP NAT translation. So now I can remove that. Done. Similarly, I need to say no. See this command. So here we use the full 3 different IP addresses, right? So in the pat, I will use same IP address. So what I am going to use the same command. I'm going to say whatever it is, my starting and end both are 10 only. And finally, what I'm going to say IP NAT source IP NAT inside list. Okay. IP NAT inside list inside source list 10, and the pool is CCNA, and just one single command overload. If you put this command, so now all the translation, the overload that command is nothing but the pat. So all your translation will go to a single IP address on different port. If you go here and check, Allahu Akbar. Why it is happening again? So if I browse here something, so static NAT, dynamic NAT, and this NAT. One dot, one dot, one dot. Browse. So guys, everyone, please do this lab. I'm going to share you this PPT, no, not PPT, this one, Notepad. Use that and do this lab: static, dynamic, and default pat. So I just want to show result. So okay, so IP NAT translation. Can you see? Now see here all IP addresses for 11, 10, and 20. 10, 11, and 12 single IP addresses mapping. But can you imagine here? See the different ports. That's it. This is the path. So what you did in the configuration? Do show history. So, or in the notepad, see just 3 commands you used. So you need to create the access list to say what is your LAN. You need to create a pool saying that what is your public IP addresses. So if you have multiple, then use this one. So that will become dynamic. So in the pat, you have single IP address. Start and end is the same, and the same is you map this pool to, and finally overload. That's it. Finish. So that's it. I'm going to share this one. So please do the practice. We'll meet tomorrow. Okay. Bye. Shahid, you can use this.